So it says table salt, NaCl, and sugar C12H22O11 are accidentally mixed. A 4.50 gram sample is burned and 1.0 grams of CO2 is produced. What was the mass percentage of table salt in the mixture? So let's look at our kind of question here. So we have NaCl, and we have sugar, which is C12H22O11, and they're mixed, right? Okay, that's fine. Accidentally mixed. A 4.50 sample is burned, and 1.80 grams of table salt in the mixture, right? So what they're asking, 1.0 of carbon dioxide is produced. What was the mass percentage of table salt in the mixture? So we're given our sample here. 4.50 grams of sample is burned, and 1.0 grams of calcium dioxide is produced, right? So and then it's also asking us what is the mass percentage. So in order for us to look at this question, we have to think about, okay, it's this chemical reaction of combustion, right? It's burned, right? So when we take a look at sodium chloride and sugar, which one of these will burn more easily? Sodium chloride or sugar, right? In this case, sugar actually burns more easily. Sugar caramelizes at about 180 degrees. So in this case, we can say that a chemical reaction we can write is with sugar here, which is C12H22O11 plus oxygen gives us. I'm going to assume it's a complete combustion, and it gives us this equation here. So we have sugar plus oxygen, and burning it gives me water and carbon dioxide, which is good. I can balance this chemical equation as well. So there's 12 carbons on this side, which means I need 12 carbons on this side. So I'm going to write 12 here. Hydrogen, there's 22, and I only have 2 on this side, which means I need 11 hydrogens here. And finally, I have 11 hydrogen or oxygen, sorry, and then I have 24 oxygen. So I have 11 oxygens plus I have 24 here, which means I need 35. So I need 35 over 2 here. And if I want to get rid of the decimal, I have to multiply the entire thing by 2. So I'm saying this here is 2. This becomes 35. This here becomes 22. And this here becomes 24. Okay, so we have our balanced chemical equation for this problem here. It is, so we have 2, 35, 22, and 24. Okay, and it's asking a 4.5 gram sample is burned, right? And 1.80 grams of CO2 is produced. So let's in this sense, let's work backwards, right? So we have grams here. So let's make our kind of mass table. Mass, so this is mass, molar mass, and moles, right? So we have these types of things here. And so we're making our kind of table here. We have 1, 2, 3, and 4, right? And we're given our mass of CO2. So mass of CO2 is 1.80 grams, right? So what we have to figure out, let's figure out the molar mass of this CO2 first. So in order for us to do that, I simply have to do molar mass. So again, the chemical equation for this would be, I'll write this in blue, would be moles equals mass over molar mass. So therefore, molar mass. So therefore, I can figure out molar mass using the periodic table, right? So again, I have carbon, CO2, right? So C here is 12.01, plus, and I have 2 O2s, right? CO2. So I have 2 times 16 here to give us our molar mass of carbon dioxide, which is 44.01, right? So in this case, my molar mass of CO2 is 44.01. That's great. This isn't grams per mole. I just don't have space here. So let me just write down, this is grams per mole here. Super small. And then now moles is obviously mass divided by molar mass, like stated before. So I'm going to take 1.80 divided by 44.01. And that would give me the moles of my, of my CO2 here. So this here is 0.041. So this is 0.04. I'll do 0.9 here. That's fine. And then what we can do is we can actually use kind of a mole to mole ratio to figure out how much sugar we have in the first place, right? So that's kind of how we find out the grams of sugar in the sample here. And then what we can do is we can take the mass percentage. So in order for us to do that, if we have 24 moles of, or the coefficient here is 24, and we have this is the moles of it in total, we can simply divide this 0.0409 by 24 to figure out how much moles, or 1 mole of CO2 is here. So we have 0.0409 divided by 24. So we have this is now 1.70. So let me write this down. This is 1.70. 1.70 times 10 to the negative 3. 10 to the negative 3. This is moles, and this is per 1 mole, one mole of something, right? So once we have this, we have a coefficient of 2 here, right? So what we have to do is we have to actually multiply this number by 2 to figure out the moles of sugar in our compound. So if we multiply this number by 2, we would get we have 3.41. So this is 3.41 times 10 to the negative 3 moles. That's good. So once we have this, what we can do is work it backwards and work towards our grams of sugar here, right? So let's figure out the molar mass of this first. So the molar mass here, again, I have 12 carbons, 22 hydrogens, and 11 oxygens. So 12 carbons. I know my molar mass of the atomic mass of carbon is 12, so it's 12 times 12. Plus, I have 22 times 1, right? Again, my atomic mass of hydrogen is 1, so I'm multiplying that by 22. Plus, I have 11 oxygens times 16, which is the atomic mass of oxygen here, which makes a grand total of 342 grams per mole. 342 grams per mole. And if I want to figure out mass, I simply just have to multiply moles and molar mass together, right? So 342 times, this is 3.41 times 10 to the negative 3 would give me 1.16. This is 1.1666 grams of sugar, right? So now we know the grams of sugar in this case in our sample, which means we can find our table salt, right? Because we have our total mass here. I'll just in blue. Because our total mass, or total here, equals 4.50, right? And this was a mixture of sugar and salt. But if we know our mass of sugar here, we can simply just subtract. If we want to find our mass of our salt here, simply have to take the total mass, 5.0 grams, minus 1.166, which is the mass of our sugar here, to finally get our mass of salt, which is simply equals 4.50 minus 1.166. This will give me 3.334 grams. And then from that, we can figure out the mass percentage, right? For the mass percentage, what we can, on the mixture is simply, so the mass, I'm going to do it percent equals, again, it's going to be the mass of our NaCl, of our salt, over the total mass times 100%. This here equals, so again, this is 3.334 grams divided by the total mass, which is 4.50 grams, times 100%. And this entire thing will give us our mass percent of our problem. So this is 3.334 divided by 4.50 times 100%. 0.50 times 100%, and this will give us an answer of 74.09%. So this here is my solution for this problem, 74.09%, and then I can always go back to our significant digits to figure out how many significant digits I have. In this case, I have 3, so therefore our answer here is 74.1% is our mass percentage of NaCl. So let me just scroll down and see if our answer is correct. So they have 58, which means our answer here, there's a discrepancy in our answer. So let's look at this problem here. So they balanced here. This is C12H22011, and they balanced 22 and 24. Okay, that's fine. So I multiplied everything by 2, which is fine. Now 2.90 moles of CO2 is equal to, where did they get 2.09 moles? I'm very confused. Where did they get this number from? 2.90. They didn't get it from the question. They don't have, yeah, they didn't get that from the question at all. So again, I don't know how they got the mass of moles of CO2 is equal to, this here's the moles divided by, this is the mass? I'm not sure what they did here. Give me a second. So this 1.80 of CO2 is produced. And they're saying this is simply the moles. I think they meant to write the mass here, the mass of CO2 here instead of the moles of CO2, which means it threw off their entire answer. Because 2.90 is the number that they took out of thin air. I don't know where they got this moles here. Also, 2.90 moles divided by grams per mole does not give us moles here. The unit analysis here is wrong as well. According to the equation, the amount of sugar we'll produce is 1/12. That's fine. So they did this math perfect, and they multiplied to get grams, subtracted it, and divided the 2.62 by the total amount, right? So this here solution is actually incorrect because of that first problem. They're incorrect. It's this question here. How did you get from the question? So I think you meant to divide the mass of CO2 by the molar mass of CO2 to get the number of moles in CO2. The logic for the rest of the question is correct. So again, this here's question is incorrect because I solved this problem using, again, I have the grams of CO2. I was given that in the first place. So 1.080 is grams of CO2. And I'm dividing that by, again, dividing by that by 44.01 to get our moles here. And in this first problem here, they already messed up here because this is 2.90 divided by 44.01. So this here is incorrect. Solution here is incorrect.